So in this video, I'm gonna run through a bunch of examples of graphing sine and cosine when there's some type of transformation applied to it. So basically, to be able to follow this video, you need to know what the basic graph of cosine looks like. It starts at the top, goes down to 0, down to the bottom, back up to the top, and all that's done by 2 pi. Same way with sine, we know that it starts at the middle, goes up to the top, down to the middle, down to the bottom, and back up to the middle. And all that happens before 2 pi. And it's symmetrical. The halfway point is pi. Halfway point here is pi, etc. Okay? Then we also know this basic idea that y equals the amplitude times the sine or cosine function times the frequency plus the vertical shift. Okay? So when I look at this thing here, y equals 2 cosine x, my first thought is the amplitude is 2 and everything else is normal. So that means the period is going to be the same, the middle is going to be the same. So all I'm going to do is I'm going to draw a graph just like that one, but it has an amplitude of 2. So we'll draw like this. I'm going to go out here to 2 pi, and we go 1, 2, 1, negative 2. So cosine is going to start at the top, right? That's what this tells me. Let me grab a different color here. Cosine is going to start at the top. It's going to hit the bottom halfway through here, so that's at pi, right? Now, one thing I like to do, I think I showed in the other video, is put in a little dotted line where the top is and a dotted line where the bottom is, so I never get confused. And I know the middle is at the x-axis, so I don't need to draw that one in. So I'm going to go start at the top, go down to the middle, hit the bottom, come back up to the middle, and back to the top. And everything should be symmetrical, meaning that the time it takes me to go from top to the middle is the same as the time it takes me to go from middle to bottom, which is the same as it takes to go from here to here, and the same time it takes to go from there to there. So these spaces should be even. You should have even spacing on your cosine and sine curves. Okay? So that's the first one. So let's draw this next one. This is another cosine curve. Now notice in this case the amplitude is not changed. But the vertical shift happens. So remember, when a vertical shift happens, I take care of that by putting in a dotted line for the new middle. And the top, since the amplitude is 1, it's only going to go up 1 from here. So that's 1, that's 2. And the bottom is going to be at the x-axis here. So let's grab a green again. So when I graph this thing, I'm going to start at the top, right? But this, what does this 2 do? That 2 is a frequency, which means it shrinks the period down. And we have this handy little formula that we got in the last one, that we know that the period is equal to 2 pi divided by the frequency. So that means the new period is pi. So that means this thing's going to go from the top. So it's going to go from the top down to the bottom, back up to the top, all by pi instead of 2 pi. So I'm going to go out here and put a little pi right about there. So the halfway point is going to be pi over 2. So I'm going to start at the top, and I'm going to go from there down to the bottom by pi over 2, back up to the top by pi. And again, looking for that even spacing, so that means that it's going to hit the middle at pi over 4. It's going to hit the middle again at 3 pi over 4. Because I'm keeping that nice even spacing. Okay, we're going to skip 3 for a minute and come back to it. So number 4, this is the same thing as that without the shift, but it's sine now. So let me grab the black, put in my axis. So we know that the period of this thing is going to be 2 pi divided by the frequency, which is 2, so the period is pi. So I'm going to go out here and put in a pi there. That means halfway would be at pi over 2. But now I'm picturing this graph up here, right? Because that's the sine graph. So, and everything else is the same. My amplitude is 1, so it's only going to go up to 1. The top will be at 1. The bottom will be at -1. And sine starts in the middle, so I'm going to start right here. I'm going to go up and back down before I get to pi over 2, and down to the bottom and back up by the time I get to pi. Okay? Okay. Now on this one, I think I'm ready to tackle this one. This one's, we didn't talk about this in the first video. But first thing I notice is this vertical shift of 1. So I'm going to go up here and my new middle is at 1. The amplitude is 1, so the top is going to be at 2. The bottom will be at the x-axis. And everything else is the same. So the amplitude is the same. The period is normal. The period is going to be 2 pi, because I'm not multiplying anything on the inside here. So the only thing that's different is this little negative pi over 2. Now if you remember in pre-cal 1 days, adding or subtracting on the inside shifts to the right and left. And remember, there's an opposite effect. So when I subtract, it shifts to the right. When I add, it shifts to the left. So this is going to shift my graph to the right pi over 2. So sine normally would start right here at the middle. Let's put in my little 2 pi out here. So that's 2 pi. About halfway is pi. And a quarter of the way is pi over 2. Okay? So normally, sine would start at the middle here and go up. That's what it would normally do, right? But we'll use blue to do that, what it actually does. But because I'm shifting everything to the right pi over 2, instead of starting here, it's going to start right here. See how that's shifting it to the right pi over 2? So just like normally it would go up and hit the top at pi over 2, this is going to go up and hit the top at pi, because it's been shifted, everything's been shifted to the right pi over 2. So this, the normal curve would have went up and hit the top right there. So that means this one's going to go up and hit the top pi over 2 to the right. And again, normally this would have, without the pi over 2 shift, this would have came back down to the middle by pi. So that means this one's going to come back down to the middle by 3 pi over 2. And then normally, without the shift, this would have went down to the bottom right there. So this guy is going to go down to the bottom at 2 pi. And then this one would have came up to the, whoops, sorry. This thing would have came back up to the middle by 2 pi. So that means this one's going to come back up to the middle by 5 pi over 2. So if we finish this off, it would have come back down there, etc. Okay, so you can see that little shift. So let's erase that green line now. There we go. Okay. Next one, cosine of 1/2 x. So again, I'm going to grab my black axis here and go. Let's see. The amplitude is normal. The shift, there is no vertical shift or horizontal shift. So the only thing that's different here is the frequency. So we know that period is equal to 2 pi divided by the frequency. So that would be, the period is 4 pi. So I'm going to go out here a long ways and put in my 4 pi. Halfway would be 2 pi, and a quarter of the way would be pi, so that would be 3 pi there. And my top is going to be at 1, my bottom is going to be at -1, and everything else is going to be normal. So this is a cosine curve, so it starts at the top and goes down, but that means it's going to start here, halfway it'll be at the bottom, and all the way it'll be up here back at the top again, because that period is 4 pi. So now I just got to draw this. So notice I'm hitting, again, keeping that even pacing. Okay. Next one, number 6. I didn't really leave room for it, so I'll hop down here below and draw it. So this has an amplitude of 2 and a frequency of 2, which means my period is equal to 2 pi divided by 2, which would be pi. Okay, so that means, and it's sine, so I have to finish by the time I get to pi, which means halfway would be pi over 2. Okay, and this thing's going to go up to 2 and down to negative 2. Since it's sine, I'm going to start in the middle because it hasn't been shifted to the right or left. So I'm going to start right there at the origin. And I'm going to go here, put my little dotted lines up here so I know I don't go past them. So I'm going to go up to the top and back down, and then down to the bottom and back up before I get to pi. And that period is pi. Of course, this would just keep going in a similar fashion, etc. All right, so that's 6. Number 7, write the equation for each of the following. So now we're going the opposite direction. We're going to get a quick sketch of this. So this says has a maximum point at pi. So let's go pi. There's pi. There's 2 pi. Maximum point of 5. And a minimum point of 2 pi 1. So you can kind of picture a curve like this, right? So sinusoidal means I can use sine or cosine. And let's go backwards. If this goes down to the bottom at 2 pi, that means I also would hit the bottom at 0. Because, again, because that symmetry thing, this distance, that distance should be the same as, so this should be the same as that. It doesn't really look at it that way, but that's what it should be, the same, right? So that I know if it takes me pi going this way to get to the minimum, it should also take me pi going backwards to get to the minimum. So that means I'm starting at the bottom, okay, on the y-axis. So that makes me immediately think of y equals negative cosine. Because if you flip cosine upside down, it would start at the bottom and go to the top, right? So then we just got to figure out amplitude. So amplitude is going to be, easy way to find the amplitude is the maximum minus the minimum divided by 2. Because remember, amplitude is how far I am from the middle to the top or from the middle to the bottom. So in this case, that would be 5 minus 1, which is 4, divided by 2, which would be 2. So the amplitude is 2. So this equation is going to be negative 2 cosine. Now, I don't need any horizontal shift because I can tell that this thing starts at the bottom and the negative took care of that. But I do need to change the period. Do I? Nope. The period is 2 pi, right? So it starts to repeat itself after 2 pi. You can see that this part here is the same as that part there, right? Okay. So we can just put a normal old x in here. That doesn't need to change. And then the last thing is, has it been shifted vertically? And we know, yes, it indeed has, because the center of this graph is not on the x-axis. So we want to find out how far above the x-axis is it, or we just need to know what the middle is. So the middle, remember, is going to be 2 above the bottom or 2 below the top, because that's how amplitude is found, right? So since the bottom is 1, that means the new middle must be equal to 3. Because I'm going from 1 up 2 to get to 3. So that means I need to shift it up 3. Because I'm going to shift the middle. Because if the middle shifts 3, that means everything will shift 3. So notice that if I go up 2 from 3, that'll give me a top of 5. And if I go down 2 from 3, that'll give me a bottom of 1. So that right there would be the equation that gives me those points. Okay, we have 2 more here. Sinusoidal curve, again, sinusoidal means sine or cosine. That has a period of pi. That should be pretty easy. So I'm going to go y equals. So how do I get a period of pi? Well, remember that if I want to know what the frequency is, I can go 2 pi divided by period. So in this case, it would be 2 pi divided by pi. So that means my frequency is 2. So I need a 2x in here. Has an amplitude of 2. Well, that's easy. I just put a 2 out front. And that has not been shifted at all. So I guess it doesn't tell me whether you sine or cosine. So I'll just put in sine. You could put cosine here. It doesn't matter. Has not been shifted at all. So there we're done. We took care of the amplitude, took care of the period, and again, so you could put 2 sine 2x or 2 cosine 2x because it didn't tell me which curve to use. Okay? Finally, a sine curve that has been shifted vertically 2. So it's a sine curve now, so I'm going to y equals something involving sine. It's been shifted vertically 2, so I'll put a little plus 2 out here. Has a period of 2 pi. That means that I don't need any kind of multiplication in here, but has been shifted horizontally pi over 4. So that means I'm going to do an x in here and put a minus pi over 4. Because if I subtract pi over 4 in the equation, that'll shift it horizontally positive pi over 4. So this would indicate since I didn't say horizontally negative pi over 4, that means I'm shifting to the right pi over 4. Okay? It doesn't mention anything about the amplitude in here, so I just leave the amplitude as 1. Alright, so hopefully this is helping you get a hang of how to graph sine and cosine when it's got some transformations applied to it.